Tonight, we journey beyond the edge of everything you've ever known. Imagine, if you will, that you are floating in the profound darkness of space, suspended between the stars, untethered from the familiar world below. The universe stretches endlessly around you in all directions, not with violence, but with a kind of patient, ancient stillness. And somewhere in this infinite expanse, in a region of the cosmos that should not exist according to the rules we thought we understood, the James Webb Space Telescope has detected something. Something that quietly, persistently, challenges the very foundation of how we understand time itself. Before we drift deeper into this mystery, I want to invite you to settle into a comfortable place. Perhaps you're lying in bed, or perhaps you've found a quiet corner where the world feels far away. This story is meant to unfold slowly, like a dream that gradually reveals its meaning. There's no rush. We have all the time in the universe, quite literally, to explore this together. So allow yourself to relax, to let your breathing settle into its own natural rhythm, and to open your mind to the extraordinary journey ahead. Now, let's begin by returning to where everything we know began, or where we thought everything began. For nearly a century, we have held a particular belief about the universe and its origins. We've called it the Big Bang. Picture this moment in your mind. Approximately 13.8 billion years ago, all the matter, all the energy, all of space and time itself was compressed into an infinitely small, infinitely dense point. And then, in a moment beyond our comprehension, it exploded. Not into space, but space itself came into being through that explosion. For a very long time, this felt like the most profound truth we could possibly grasp. The Big Bang was our universe's birthday, our cosmic origin story. Everything we see today, every star, every galaxy, every planet, including this one where you rest tonight, emerged from those first moments. The light from the earliest objects in the universe, we believed, could not possibly be older than about 13.8 billion years. This was, to us, the absolute boundary of time, the edge beyond which nothing could exist. But then something extraordinary happened. A new telescope looked out into the cosmos with eyes more powerful than any instrument humanity has ever created. The James Webb Space Telescope, orbiting nearly 1 million miles from Earth, pointed its massive mirror toward the deepest, darkest regions of space. And there, in those regions, it discovered galaxies. Ancient galaxies. Galaxies that glowed with light, suggesting they had been burning and shining for billions of years already. Galaxies that, by all our calculations, should have taken much longer to form. And yet, the light from these galaxies told a different story. The light whispered of ages far greater than our equations had predicted. The light sang of a universe that works according to rules we had not yet discovered. This is where our mystery truly begins. Before we untangle what it means, let me paint for you a clearer picture of what we're actually discussing. When astronomers look at distant objects through a telescope, they are not just seeing those objects as they exist today. They are seeing them as they existed in the past. Light, you see, takes time to travel. The light from the sun that touches your face right now left that star about 8 minutes ago. When you look at the moon, you see it as it was slightly more than a second in the past. But when we look at the most distant galaxies, we are looking back in time by billions of years. The James Webb Space Telescope is, in many ways, a time machine. Its infrared eyes can detect light that has been traveling through the universe since the very earliest moments after the Big Bang. As it turned its attention toward the deepest regions of space, it began sending back images and data that slowly, surely, started to contradict what we thought we knew. And this is where the universe becomes truly mysterious. The galaxies that Webb observed weren't just old, they appeared to be impossibly old. Some of them showed characteristics suggesting they had been forming and maturing for billions of years before they should have even existed, according to our current models. It's as if you looked out your window and saw trees that were 1,000 years old in a forest that, by your best estimates, should only be 500 years old. Something doesn't add up. Something is calling us to look deeper, to question more carefully, to wonder about the true nature of the cosmos we inhabit. Now, as your eyes grow heavier and your mind settles into the rhythm of this story, consider what this means. Consider that the universe we live in, the one you've been told, has a very specific beginning, a very specific age, might be more complex, more mysterious, more strange than anyone ever imagined. The boundaries we thought we had drawn around reality are beginning to blur. The edges of our understanding are becoming less certain, less defined. But there's more to this discovery than simple age, than galaxies being older than expected. There's a deeper puzzle here, one that touches on the very nature of existence itself. You see, these galaxies that Webb found, these ancient light bringers from the cosmic dawn, they exist in a state that should be impossible. They appear fully formed, mature, complex, and this in itself tells us something crucial about how the universe works. Imagine you found a newborn child who could already walk, speak, and reason like an adult. This would be impossible in our world, wouldn't it? The laws of growth and development would have to be broken. And yet, in the universe that Webb is revealing to us, something similar seems to be happening. Galaxies that should still be infants appear to be fully grown. Let me walk you through the reasoning here, gently, allowing the ideas to settle slowly into your understanding. In the early universe, right after the Big Bang, everything was far simpler. Galaxies were smaller, younger, less complex. They built themselves up over time, merging together, growing larger, developing the intricate spiral and elliptical structures we see today. This process takes billions of years. It takes nearly as long as the age of the universe itself. And yet, when Webb pointed its mirror at the ancient cosmos, it found galaxies that had apparently completed this billion-year journey in just a few 100 million years after the Big Bang. They had grown at a rate that seems to defy the natural laws of cosmic construction. This contradiction, this impossible situation, is what brings us to the very question that has begun to spread through the scientific community like ripples in an infinite pond. What if our understanding of the Big Bang itself needs to be revised? What if there was something before it? Or what if it happened differently than we believed? What if the universe is older than we thought? And slowly, gently, as your breathing deepens and the world around you fades into shadow, consider this. For our entire history as a species, we have believed that we understood the moment of creation. We had put boundaries on infinity. We had measured the immeasurable. But the universe, it seems, has been keeping secrets. The universe has been waiting, patiently, for us to ask better questions. These are the questions we will explore together as we journey deeper into this night. Not with urgency, not with fear, but with wonder. With the calm certainty that the universe, despite its mysteries, continues to reveal its secrets to those patient enough to listen. Imagine standing in the darkness of a desert on a moonless night. You cannot see your hand before your face, but if you remain still and allow your eyes to adjust, details begin to emerge from the blackness. A faint glow appears here and there. The shapes of distant hills become visible. The universe reveals itself not to violence, not to force, but to patience and stillness. This is what the James Webb Space Telescope does. It is the human eye finally learning to see in the deepest darkness, finally patient enough to perceive what has always been there. The James Webb Space Telescope is not the first instrument we have sent to study the cosmos. Before it came the Hubble Space Telescope, an instrument that transformed our understanding of the universe in the 1990s and beyond. Hubble was remarkable. It showed us galaxies where we thought there was nothing but empty space. It revealed to us that the universe was expanding, that distant galaxies were flying away from each other, that the cosmos had a history, a narrative arc that stretched back towards some beginning point. But Hubble, impressive as it was, had limitations. It was designed primarily to see invisible light and ultraviolet wavelengths, the same light our human eyes can perceive. extended slightly beyond our natural vision. And visible light, while revealing in its own way, is limited. It is scattered and absorbed by cosmic dust. It cannot penetrate through the clouds of gas where new stars are being born. It shows us the universe in bright colors and clear shapes, but it shows us only a portion of the full story. Then came James Webb, designed to see primarily in infrared wavelengths. Webb peeks through the cosmic dust as easily as you might look through a window of frosted glass. It was launched in December of 2021 and has been slowly, methodically, revealing a universe far stranger and more complex than Hubble ever could show us. Infrared light, the kind of radiation that carries heat and warmth, travels through dust and gas that would stop visible light entirely. And so Webb, positioned at a distance of nearly 1 million miles from Earth, became our eye into the cosmic infrared, our window into the universe, as it was in its earliest moments. What makes this particular discovery so remarkable is not simply that Webb found old galaxies. In some sense, scientists expected to find ancient galaxies. What they did not expect, what has created the profound mystery we're exploring tonight, is that these galaxies were so mature, so well developed, when they should have been merely infants in cosmic terms. Think of it this way. The universe, as we've understood it, is like a massive tree growing from a seed. That seed is the Big Bang. In the very beginning, right at the moment of the Big Bang, there is just the potential. And then, slowly, over billions of years, the universe grows and develops. Stars form. Galaxies assemble. Complexity emerges from simplicity. This growth is not instantaneous. The laws of gravity work slowly, patiently, bringing matter together across vast distances and immense spans of time. And yet, when Webb began to see clearly into the cosmic past, it found galaxies that appeared to have grown far too quickly. Galaxies with billions of stars, with complex structures, with the signatures of billions of years of stellar evolution, appearing in a universe that was barely 1 billion years old. It was, from the perspective of modern cosmology, profoundly unsettling. The math didn't work. The physics seemed to be broken. Now, as you continue to rest and allow your mind to drift through these cosmic concepts, understand that this is not a failure of the telescope or an error in the data. Webb has been carefully calibrated and repeatedly checked. The observations are real. The universe is genuinely showing us galaxies that are far older than our models predict they should be. The discrepancy is not a problem with our instrument. The problem, if we can call it that, is with our understanding of the universe itself. This is actually the beautiful part of science, the part that often gets lost when we think of scientific knowledge as fixed and unchanging. Science is not a collection of absolute truths carved in stone. Science is a conversation between human beings and the natural world. We ask a question, we observe, we develop a model to explain what we see. And sometimes the universe answers in a way that surprises us. The universe tells us that our model was incomplete, that we were looking at only part of the picture. And so we must revise. We must deepen our understanding. We must ask better questions. And this is what Webb is forcing us to do. Consider the timeline for a moment, and let your mind move through it as though you are floating along a river of time. 13.8 billion years ago, or at least, that's what we thought the Big Bang occurs. The universe is born. For the first few 100 million years, there is nothing but hydrogen and helium gas, cooling slowly from the immense heat of creation. Gravity begins to work. The gas gathers together. Stars ignite in the darkness, their fusion cores burning for the first time. These early stars are massive and short-lived, burning furiously and dying young. But as stars die, they release elements into space. These elements gather, form new stars, new planets. Complexity increases. Galaxies begin to form, slowly, gradually, from the coalescence of gas and dark matter. According to our models, this process takes a very long time. A galaxy similar in size and complexity to our Milky Way should take several billion years to assemble. And yet, Webb is showing us galaxies that look like our Milky Way, or even more massive, appearing when the universe was only 1 or 2 billion years old. It's as if the universe has been following a recipe that allowed it to speed up its own development. It's as if the laws of physics operate faster than we had calculated. Or it's as if there was more time before the Big Bang than we previously understood. Each possibility carries with it profound implications. And here's where we approach something even more mysterious, something that will become the thread we follow through the rest of our journey together. If these galaxies truly are older than our models predict, then either the universe is older than we thought, or it has worked differently than we imagined. And if the universe is older than we thought, then perhaps it was not created in the Big Bang at all, but existed before it. Perhaps the Big Bang was not the true beginning, but merely a transition, a transformation in a cosmos that was already ancient. This idea, this possibility, challenges everything we've built our modern understanding upon. But it's a challenge worth taking seriously. It's a possibility worth exploring, slowly and carefully, as we drift deeper into the night together. The telescope that made this discovery sits in the eternal cold and darkness of space, continuously gathering light that has traveled for billions of years. That light carries information from the ancient universe, and the fact that this light has reached us at all, that we have developed the technology to detect it and interpret it, feels almost miraculous. We are seeing the universe as it was when it was young, when it was still learning to be itself. But yet, and this is the thought to rest with as we move deeper, what we are seeing challenges the very meaning of young in cosmic terms. What if our sense of time itself in the universe needs to be fundamentally revised? Let us journey now more deeply into the cosmic past, floating backward through time like a leaf drifting downstream, but moving against the current. Imagine yourself suspended in the universe, watching it age backward. Stars die and unmake themselves, their light withdrawing into darkness. Galaxies disassemble slowly, their stars dispersing like a flock of birds taking flight in reverse. And as you drift further back, the universe becomes denser, hotter, younger, or so we believed. The earliest light we can observe comes from a time known as the Cosmic Dark Ages. This period, stretching from perhaps 100 million years to about 1 billion years after the Big Bang, is when the universe was finally cool enough for the first stars to form. Before this time, everything was too hot, too violent, too chaotic for stable structures to exist. But as the universe expanded and cooled, gravity, that most patient of all forces, could finally bring matter together. And stars were born. These first stars were not like the sun you see during the day. They were massive, enormous, burning with an intensity almost impossible to imagine. A single star from the early universe could outshine billions of stars like our sun. They lived fast and died young, burning themselves to ashes in just a few million years. But when they died, they did something remarkable. In their final moments, in the fury of their collapse, they created elements heavier than hydrogen and helium. Iron, oxygen, carbon, nitrogen, all the elements necessary for complexity, for chemistry, eventually, for life. Now, here is where the story begins to become strange. A next generation of stars formed from these enriched materials. They too burned and died, adding more complexity, more elements to the cosmic mix. And very gradually, perhaps over hundreds of millions of years, the first galaxies began to coalesce. Small star clusters merged together, drawn by gravity. Gas clouds collapsed and fragmented into billions of stars. Slowly, patiently, cosmic structures built themselves up from the chaos. This process, as astronomers have understood it, is not fast. It is not quick. It is the opposite of quick. It is the ultimate expression of slowness, of gradual change occurring over geological and cosmic scales that dwarf the human imagination. Building a galaxy the size of the Milky Way, a collection of hundreds, of billions of stars should take nearly as long as the age of the universe itself. Yet Webb is showing us that this didn't happen the way we thought. When the telescope turned its infrared gaze toward the earliest regions of cosmic time, it found what should not be there. It found fully formed, mature galaxies that by all calculations should have been tiny, primitive affairs. It found galaxies with clear spiral structures, with rotating disks, with the kind of complexity that takes billions of years of merging and interaction to develop. It found galaxies that shone brightly, suggesting they contained billions of stars, in a universe that should have had barely enough time to create a few million stars per galaxy. The observations were confirmed again and again. Webb wasn't malfunctioning. The data wasn't misinterpreted. The universe was simply not behaving according to our theoretical predictions. And so a profound question began to emerge from the scientific community, whispered first in private, then discussed openly at conferences, then investigated seriously through new research. What if something is fundamentally wrong with our understanding of cosmic time? Consider for a moment what this would mean. If the universe somehow created mature galaxies much more rapidly than our physics predicts it should, then perhaps the universe itself was not as we thought. Perhaps the very constants of physics, the numbers that describe how gravity works, how fast light travels, how matter and energy interact, are not fixed, as we've assumed, but changing. Or perhaps the universe is older than we thought. Perhaps there was something before the Big Bang. Now, the first option that the laws of physics might change is troubling, but perhaps manageable. Scientists can accommodate changing constants. There are theoretical frameworks that allow for such things. But the second option, the idea that the universe might be older than the Big Bang, cuts to the heart of everything we thought we understood about existence itself. For over a century, the Big Bang has been our origin myth as a scientific civilization. It is where we placed the beginning of everything. To suggest that there was something before it, some previous cosmic epoch, some forgotten universe before our own, this is to suggest that our founding cosmological story is incomplete. And yet, there are whispers of such ideas in the corridors of physics. There are theoretical models, proposed by thoughtful scientists, that suggest the universe might cycle, that Big Bangs might not be singularities but transitions, that there might be a universe before our universe, ancient and distant, fading into an unimaginable past. These are not mainstream ideas, not yet, but they are serious ideas, held by serious researchers. And Webb's observations have given these ideas new currency, new weight, new reason to be taken seriously. Let me paint a different picture for you now, one that rests more gently on the boundaries of what we know and what we conjecture. Imagine that the universe is not a simple story with a clear beginning, but something far more complex. Imagine that what we call the Big Bang is not truly the beginning of everything, but a transformation, a phase transition in a cosmos that was already ancient. In this picture, before what we call the Big Bang, there might have been another universe, perhaps very different from our own. That universe was ancient, perhaps infinitely old. And then something happened. Something caused a transition, a transformation, an expansion. And what we see now, what we study as the Big Bang, was not the true beginning, but merely the beginning of our current cosmic phase. In this picture, Webb's ancient galaxies are not paradoxes. They are not impossibilities. They are simply evidence of a universe that had more time to develop than we previously thought. They are fossils from a cosmos that is older, far older, than 13.8 billion years. But I offer this not as truth. We must be careful about that, but as possibility. As one way of thinking about what Webb might be telling us. The full answer, the complete picture, has not yet been revealed. The universe keeps its deepest secrets close. And as you drift further into relaxation, let your mind settle on this thought. The universe is stranger and more vast than any of us, with our limited perspectives, can fully comprehend. And perhaps that is exactly as it should be. Perhaps the universe is meant to be a mystery that we are only gradually, slowly, learning to understand. And that mystery itself, that profound unknown, is perhaps the most beautiful and sacred thing we can contemplate as we rest in the darkness. To understand what is happening in the universe, Webb is revealing, we must understand the language in which the universe speaks. And that language is mathematics. Mathematics is not the cold, abstract thing we sometimes imagine it to be. Mathematics is, in fact, a kind of poetry, a way of describing the deepest patterns and relationships that underlie all of reality. And in the mathematics of galaxies, the universe has written something very strange indeed. When astronomers observe distant galaxies, they collect light. This light has traveled for billions of years, carrying encoded within it information about the galaxy that emitted it. The wavelength of the light, its color, tells us about the composition of the stars within that galaxy. The brightness of the light tells us about the number of stars. The spectrum, the full rainbow of light at all different wavelengths, tells us about the age of the galaxy, the rate at which stars are being formed, the metals present in the interstellar gas. From all of this information, astronomers can deduce how old a galaxy is. They can determine, with surprising accuracy, how long that galaxy has been existing as a coherent structure, how long its stars have been burning, how many generations of stellar birth and death have occurred within it. Now, let's think about this carefully. Imagine a galaxy that Webb observes in the universe, when the universe itself is only about 300 million years old. By what we know about how galaxies assemble, this galaxy should have started forming when the universe was already a few 100 million years old. And so it should have only about 100 or 200 million years of existence since its formation began. In that time, how many star generations should it have gone through? Stars, particularly the massive early stars, live very short lives on cosmic timescales. They might burn for just a few million years. That's like a human living for a few seconds. If we took 200 million years and divided it by the lifespan of a generation of stars, we might get, say, 20 or 30 generations of stars. But the galaxy Webb is observing is showing signs of many more generations than this. It appears to have undergone billions of years of stellar evolution and galactic maturation, compressed into a time frame in which only a few 100 million years have passed. It's not just impossible. It's comprehensively, thoroughly, mathematically impossible. And yet, it is what the data shows. Now, there is a specific number that has emerged from this crisis in understanding. Some of the galaxies that Webb has observed appear to be too old by a factor of as much as 1 to 2 billion years. In other words, they show signatures suggesting they are 1 billion to 2 billion years older than they should be, given the age of the universe. This is not a minor discrepancy. This is not something that can be easily explained away by adjusting our models slightly. This is evidence that something fundamental about our understanding is wrong. One possible explanation, and this one is favored by many astronomers, is that we have somehow miscalculated the ages of these galaxies. Perhaps the light we're observing has been affected by cosmic dust in a way we haven't properly accounted for. Perhaps our models for how light is absorbed and scattered through the universe need refinement. This is a reasonable explanation, and research is underway to explore it. But another possibility, one that is more profound but also more speculative, is that the galaxies are as old as they appear to be. And if that's true, then the universe must be older than we calculated. The Big Bang must have happened longer ago than 13.8 billion years. Or, more radically still, the Big Bang might not be the true beginning of the universe at all. Let's think about this for a moment. What if the universe was not created 13.8 billion years ago, but rather 15 or 16 or 20 billion years ago? What if the Big Bang happened much further in the past than our current models suggest? The universe is expanding, and by measuring how fast it's expanding and how much matter and energy it contains, we can calculate backward to determine how long ago that expansion must have started. But what if we've miscalculated something in those measurements? What if the universe is expanding at a slightly different rate than we thought, or contains slightly more or less matter than we believed? If any of these things were true, it would change our estimate of the Big Bang's timing. And a difference of just a few billion years would be enough to explain Webb's observations. The ancient galaxies would no longer be paradoxes. They would fit comfortably into a universe that had simply had more time to develop. This is where the mystery deepens, because now we have not one puzzle, but two. First, the puzzle of the ancient galaxies themselves, and second, the puzzle of why our measurements of cosmic expansion, of cosmic density, of the Big Bang's age, might be off. These two puzzles might be related, or they might be symptoms of something far larger that we don't yet understand. Some physicists have begun to propose that perhaps the Big Bang was not truly the beginning. Perhaps there was something before it. Perhaps the universe is cyclic, expanding and contracting through endless ages. Perhaps time itself, before our universe, operated differently. Perhaps there are multiple universes, and what we call the Big Bang is simply the point at which our universe became observable from within our own perspective. These ideas might sound like science fiction, and in a sense, they are. But they are science fiction, grounded in serious mathematics, explored by serious physicists. And they are being taken seriously because the data from Webb is suggesting that something in our fundamental understanding needs to change. Now, as you settle more deeply into rest, understand that this is how science actually works, not as a collection of final answers, but as an ongoing conversation between our theories and the natural world. The natural world speaks to us through telescopes and instruments, and sometimes it tells us that we were wrong. Sometimes it tells us that we need to think bigger, deeper, more broadly about the nature of reality. And this is not something to fear. This is something to wonder at. This is the universe saying, "You thought you understood me, but there is far more to comprehend." And how remarkable is that? How beautiful is it that we live in a cosmos complex and mysterious enough to always have more to teach us. Time is perhaps the most intimate thing we experience. We live inside of time, the way a fish lives inside of water. Every moment of your life, you are moving from the present into the future, from what is known into what is unknown. You remember the past, you anticipate the future, and you exist always in this infinitesimal point we call now. Time feels absolute to us. Time feels like the fundamental fabric of existence. And yet, when we study the cosmos, we discover that time itself might not be so absolute. Einstein showed us that time can slow down, speed up, bend around massive objects. Time is not separate from space, but intertwined with it into what physicists call spacetime. And the Big Bang, according to our theories, represents the moment when both space and time themselves came into being. Before the Big Bang, the very concepts of space and time might not have existed. This is a difficult concept to hold in the mind. How can there be a before if time itself didn't exist? The question is almost paradoxical. And yet, this is the framework we've been using to understand cosmic origins. The Big Bang is the creation of time itself. Everything that came before it is, quite literally, meaningless to talk about, because the concepts of before and after don't apply. But what if this framework is incomplete? What if the universe is older and stranger than this picture allows? Imagine for a moment that time itself is not a linear arrow pointing from past to future, but something cyclic, something that loops back on itself. Imagine that the universe goes through endless cycles of expansion and contraction, each one giving birth to new matter, new energy, new possibilities. In this picture, what we call the Big Bang is not the true beginning of everything, but merely the beginning of our current cycle. Before this Big Bang, there was another Big Bang and another, stretching backward in an infinite regression. Before our universe, there was another universe, ancient and perhaps vastly different from our own. Or imagine something even stranger. Imagine that time, instead of moving forward, moves outward, radiating from some central point. Imagine that the Big Bang was not a beginning point that happened a fixed number of years ago, but an ongoing process, a perpetual unfolding that is happening everywhere and when at once. In this picture, what we call 13.8 billion years might simply be a distance outward from the center, not a duration backward through time. These are not mainstream ideas. I want to be clear about that. But they are ideas that physicists have proposed. They are ideas that make sense mathematically. And they are ideas that Webb's observations might be giving us reasons to take seriously. The ancient galaxies that Webb has discovered are, in a sense, evidence that time in the universe is not what we thought it was. They are evidence that the universe has had more time to develop than our simple models suggested. And if that's true, then our understanding of cosmic time, of cosmic age, of cosmic beginning, all of these things need to be reconsidered. Now, let's think about what this means for existence itself. If the universe is older than we thought, if it extends further back into a mysterious past than we realized, what does that tell us about the nature of reality? What does it mean for existence itself? For one thing, it suggests that the universe is not fragile or recent, but ancient and robust. It suggests that the cosmos has had eons, not just billions of years, but perhaps trillions of years, or more, to develop its current complexity. It suggests that time itself is far deeper and more mysterious than we had appreciated. It also suggests something philosophical, something that goes beyond mere numbers and measurements. It suggests that existence itself is not a simple thing with a clear beginning and an implied end. It suggests that the universe might be far more mysterious and infinite in its nature than we had dared to imagine. It suggests that we, as conscious beings observing this universe, are caught up in something far grander and stranger than we can fully comprehend. Consider this. If the universe is cyclic, if Big Bangs follow Big Bangs in endless succession, then our universe is not unique. It is one of many. And the laws of physics, the constants that seem so fixed and unchanging to us, might themselves vary from cycle to cycle. The atoms that make up your body, the laws that govern your thinking, these might be specific to our particular universe, not universal constants at all. Or consider this alternative. If time itself extends infinitely backward, if the past has no beginning, then the universe might be eternal, eternally old, eternally becoming, creating itself endlessly without ever having been created. In this picture, the question, why does the universe exist, takes on a very different character. It's not something that happened once, long ago. It's something that is perpetually happening, at every moment, everywhere. These thoughts might seem dizzying, might seem to stretch the mind beyond its comfortable limits. But as you rest and allow your thoughts to drift gently through these ideas, you might notice something. You might notice that the universe, in revealing its mysteries through telescopes like Webb, is inviting us into deeper thought, deeper wonder, deeper appreciation for the profound mystery of existence. The ancient Greeks had a concept they called the infinite regress. It was a paradox. Everything must have a cause, and every cause must have a cause, stretching backward infinitely. They found this troubling. They believed that there must be something without cause, something absolutely first, something that existed necessarily. That something, they decided, must be God. Perhaps Webb is showing us that there is no such first cause. Perhaps the universe simply is eternally, without beginning or end. Perhaps existence is a kind of mystery that cannot be resolved into simpler parts, but can only be observed, wondered at, and accepted. And perhaps, in this acceptance, we find a kind of peace. The observations that Webb has made are not singular. They are not isolated anomalies that we might explain away with a single correction or adjustment to our models. Rather, they form a pattern of impossibility, a pattern that seems to suggest that our entire framework for understanding cosmic history needs revision. Allow me to describe for you, in gentle detail, what these observations are like. Imagine Webb as a time machine pointing backward through the cosmos. Every photon it receives is a messenger from the past, carrying information about the ancient universe. And as Webb observes the most distant regions of space regions so far away that their light has taken nearly 13 billion years to reach us, it finds not what we expected, but something far stranger. It finds what astronomers call ultra-red galaxies. These are galaxies that emit most of their light in the infrared, hidden from traditional telescopes, but visible to Webb. Many of these galaxies are so red, so shifted toward the infrared, that they appear to be extremely distant, and therefore extremely ancient. And when astronomers analyze the light from these galaxies, when they carefully measure the spectrum and the intensity, they calculate how many stars the galaxy contains, how long those stars have been burning, how long the galaxy has been assembling itself. And the answer, again and again, is this galaxy is too old. This galaxy has had too much time to develop. This galaxy has gone through too many cycles of star formation and star death to fit comfortably into the cosmic timeline we've constructed. One particular observation stands out in the minds of many astronomers. Webb identified a galaxy designated GNZ13, and then later, another candidate even more distant called JADES GCZ130. These are collections of billions of stars, organized into complex structures, showing signatures of billions of years of stellar evolution. And yet, according to our calculations, these galaxies existed when the universe was less than 400 million years old. For comparison, the universe is now 13.8 billion years old. That means these galaxies are being observed as they were when the universe was less than 3% of its current age. It's like observing a human being who appears to be a fully mature adult when that human is only 6 months old. The physical growth and development has happened far too quickly. The standard explanation for these observations, the explanation that allows us to keep our current models intact, is that we are somehow mistaken about the galaxy's age. Perhaps the galaxy's light has been affected by dust in a way we haven't properly accounted for. Perhaps the methods we use to determine galaxy age have subtle biases we haven't discovered yet. Perhaps there's something about the early universe's composition that we misunderstand, which would affect how we interpret the light. These explanations are scientifically reasonable. They are not desperate or unreasonable, and researchers are actively working to investigate them. But they also share a common feature. They all assume that our basic framework is correct, and that some detail needs adjustment. They assume that the Big Bang is really 13.8 billion years ago, that the expansion of the universe is what we calculated, that the universe is roughly as old as we determined. But what if all these explanations are correct, and the galaxies really are as old as they appear? Then we are forced to a more radical conclusion. Then the universe must be older than 13.8 billion years. Perhaps it's 16 billion years old. Perhaps it's 20 billion years old. Perhaps the Big Bang happened so long ago that our current dating methods are off by a significant amount. Or perhaps, and this is where we venture into deeper speculation, the Big Bang itself is not the true origin point of the universe. Perhaps what we call the Big Bang is something else, a rebirth, a transition, a phase change in an eternally existing cosmos. Some physicists have proposed a model called the cyclic universe. In this model, the universe goes through endless cycles of expansion and contraction. Each cycle begins with a kind of Big Bang, a rapid expansion from a very hot, dense state. The universe then expands for trillions of years, cooling and developing complexity. And then, eventually, gravity slows the expansion, brings it to a halt, and reverses it. The universe begins to contract, heating up again, getting denser and denser, until eventually it reaches a state similar to what we call the Big Bang. And then, instead of a singularity and an end, the universe bounces. It reverses direction and expands again. In this model, our Big Bang was not the first. There were Big Bangs before it, perhaps infinitely many. And there will be big bangs after. The universe in this picture is eternal. It has always existed and always will. What we perceive as the age of the universe, 13.8 billion years, is merely the age of our current expansion phase. But even in this model, even if the universe is cyclic, the ancient galaxies we observe would still need time to form. Unless the laws of physics themselves are different in different cycles. Unless the constants that govern how gravity works, how fast stars form and burn, how galaxies assemble, unless these constants are not truly universal, but instead vary from one cosmic cycle to the next. There's another possibility, even more speculative, called eternal inflation. In this model, the Big Bang is not a singular event that happened once, long ago, but an eternal process that is happening everywhere and always. Our Big Bang is just one bubble, one pocket universe, in an infinite foam of universes constantly being created and expanded. Each bubble has its own history, its own age, its own physical laws. Our Big Bang might have happened 13.8 billion years ago, relative to the expansion history of our own pocket universe. But in the larger context of eternal inflation, it might be eternally young or eternally old, depending on how you measure. These ideas are wild. They stretch the imagination. They move beyond what we can directly observe and test. But they are ideas that physicists have seriously proposed, and Webb's observations have given us new reason to consider them. Because the ancient galaxies are real, their light has truly reached us. The data is genuine. Something in our understanding needs to change to accommodate these observations. And the question is, what? As you float through this knowledge, as the ideas settle gently into your mind, you might begin to feel a kind of humility. The universe is far vaster and stranger than we had known. The time it has existed stretches backward into a past so distant that our minds struggle to grasp it. And we, tiny and brief, have only in the last moment of cosmic history developed the ability to observe and wonder about these things. What an extraordinary privilege! What a remarkable responsibility! There is a kind of meditation that comes from contemplating deep time. When you allow your mind to rest on the vast stretches of cosmic history, when you begin to comprehend numbers so large that they become almost unreal, something shifts inside you. Your sense of self, your sense of immediate concerns, begins to fade into proper perspective. And in that fading, there is a kind of peace. Imagine, if you will, that you can see the universe from outside of time altogether, not moving forward, not moving backward, but perceiving all of time at once. You see the ancient universe, young and hot and dense, in all its fierce turbulent beauty. You see the formation of the first stars, blazing furiously and briefly against the cosmic darkness. You see galaxies gathering themselves, merging together, growing from simplicity into magnificent complexity. You see billions upon billions of stars being born and dying. You see the emergence of planets, and on some of those planets, the emergence of life. And you see, in one small corner of one large galaxy, on one unremarkable planet, consciousness emerging, awareness, the universe becoming aware of itself. And from this perspective, existing outside of time, the question, what is the true age of the universe, becomes less urgent. What matters is that the universe exists, that it has unfolded according to its laws, that complexity has emerged, that consciousness has arisen. The specific number of years becomes almost secondary. And yet, those numbers do matter, in their way, because they tell us something about the nature of the universe we inhabit. If the universe is older than we thought, if it has existed for longer than 13.8 billion years, then it is a universe with more history, more depth, more time for everything we see to have developed. The observations from Webb are suggesting that the universe has this greater depth. The ancient galaxies are evidence of a cosmos that did not simply pop into existence from nothing. At a specific moment in the past, but rather stretched backward in time, far further than we had understood. Whether this time extension happened before what we call the Big Bang, or whether it means the Big Bang happened earlier than we calculated, the result is the same. The universe is older, deeper, stranger than we had known. Now, let me take you deeper still. Let me invite your mind to consider what we don't know about the universe. Because the observations from Webb, remarkable as they are, represent only a tiny fraction of what lies out there in the cosmos. The universe is so vast that our deepest observations barely scratch the surface of its secrets. Imagine that all the light we've ever collected from the universe, everything we've observed with all our telescopes since Galileo first pointed a primitive scope at the moon, is like a single bucket of water drawn in an infinite ocean. The ocean of light that fills the universe is vastly larger than anything we've observed. And in that unobserved light, in the radiation that hasn't reached us yet, or that we don't have the technology to detect, there may be information that would fundamentally change our understanding. There could be galaxies older still than the ones Webb has found. There could be structures larger than anything we've imagined, stretching across distances so vast that even light takes longer than the current age of the universe to traverse them. There could be patterns and regularities in the distribution of matter that we cannot yet perceive. There could be hints of physics beyond what we currently understand, hidden in the subtle patterns of radiation and matter. And perhaps, just perhaps, there are hints of universes beyond our own. Because if the universe has existed for longer than we thought, and if it is older and stranger, then perhaps it is also more populated than we believed. Perhaps our Big Bang is not unique. Perhaps there are other universes, with other galaxies, with other possibilities, existing alongside our own, or in places entirely inaccessible to us. This is not to say we have evidence for such things. We don't. These are speculations, possibilities, things that might be true, but that we cannot yet confirm. But they are possibilities that become more plausible the more we discover about the universe's true age and nature. Consider also the role of dark matter and dark energy in this expanded cosmic timeline. Dark matter is invisible stuff that makes up about 85% of all the matter in the universe. It doesn't emit light, so we can't see it directly, but we know it's there because of its gravitational effects. Dark energy is even more mysterious. It's the force that appears to be causing the universe's expansion to accelerate. We don't really know what dark energy is. It's one of the deepest mysteries in physics. If the universe is older than we thought, perhaps dark matter and dark energy have had even more time to shape the cosmos than we realized. Perhaps their effects are more subtle and profound than our current models allow. Perhaps they have been working together over eons to create the universe we observe today. As you rest deeper, allow your awareness to expand outward, to encompass the vastness and mystery of the cosmos. Feel the weight of deep time pressing gently down upon you. Understand that you are made of material that was forged in the cores of ancient stars. Understand that the atoms in your body have existed for billions of years, or perhaps for far longer than that. Understand that you are, quite literally, a small part of the universe, made conscious and aware, contemplating itself. This is not a frightening thought if we approach it with proper perspective. This is a liberating thought. You are not separate from the universe. You are not an outsider looking in. You are an expression of the universe itself, a way that the universe knows itself, experiences itself, wonders about itself. And as the universe reveals more of its mysteries through telescopes like Webb, as we discover that it is older and stranger and vaster than we had known, we are participating in that self-discovery. We are part of the universe learning about its own nature. By now, our journey together has taken us through vast territories of thought. We have moved from the recent observation Webb's discovery of ancient galaxies, backward through time to the moment of the Big Bang itself. We have questioned whether the Big Bang is truly the beginning of all things, or whether it might be one event in an infinite series. We have contemplated the possibility that the universe is older, far older, than our calculations had suggested, and we have begun to appreciate the profound mystery that underlies all of existence. Now, let us gather these threads together. Let us see how they weave into a coherent pattern, even as that pattern remains incomplete, still being revealed to us. The core observation is simple. Galaxies that appear very old exist in a universe that is very young, according to our measurements. This creates a tension. This creates a puzzle. And from this puzzle, several possible solutions have emerged. The first possibility is that we have somehow miscalculated the ages of these galaxies. This is, in many ways, the most conservative explanation. It assumes that our basic framework is correct, but that some detail needs adjustment. This is a perfectly reasonable scientific position, and many astronomers currently favor it. Research into this possibility is ongoing, and it may well prove to be correct. The second possibility is that we have miscalculated the age of the universe itself. Perhaps the cosmic microwave background, the ancient light that fills the universe and allows us to estimate the Big Bang's timing, has properties we haven't fully understood. Perhaps the expansion rate of the universe is different than we calculated. Perhaps the density of matter or the amount of dark energy is different. If any of these things were true, it would change our estimate of cosmic age, and the ancient galaxies would fit comfortably into a universe with more time. The third possibility ventures into deeper speculation, that the Big Bang is not the true beginning of the universe, but a transition point in a cosmos that was already ancient. In this scenario, the universe might be cyclic, experiencing multiple Big Bangs across endless ages. Or it might be eternally old, in a state of perpetual expansion, following an eternal inflationary process. The galaxies Webb observes would then be old not because the universe is incredibly old, but because time itself extends much further back than we realized. All three of these possibilities have implications. All three suggest that the universe is more complex, more mysterious, and more profound than we had previously understood. All three invite us to deeper thinking about the nature of existence itself. But here's something important to understand. The answer might be a combination of these possibilities, rather than one or the other. Perhaps our calculations of galaxy age are slightly off, and the Big Bang's age is slightly off, and the true age of the universe is somewhat older than 13.8 billion years, but not vastly older. Perhaps multiple factors have contributed to the puzzle we now observe. Or perhaps the answer is something we haven't yet conceived of. Perhaps there is some physical principle, some fundamental law of the universe that we don't yet understand, which explains how galaxies could develop so quickly in the early universe. Perhaps the young universe operated according to different rules than the present-day universe, rules that would permit rapid galaxy formation that is now impossible. This is, in fact, the beautiful thing about science. The universe is under no obligation to fit our theories. The universe simply is, and we are learning step by step to understand its nature more completely. Each mystery solved reveals deeper mysteries beyond. Each question answered leads to new questions. The universe is endlessly profound. Webb's observations, therefore, are not a failure or a crisis in science. They are an invitation. They are the universe saying, "You thought you understood me, but there is far more here than you had realized." And how wonderful is that? How remarkable to live in a cosmos that continues to surprise us, to challenge us, to draw us deeper into wonder and contemplation. As you rest now, understanding more deeply how vast and mysterious the universe truly is, consider what this means for human knowledge in general. If we can be wrong about something as fundamental as the age of the universe, what else might we be wrong about? What other mysteries might be hiding in plain sight, revealed only when we develop the right instruments to perceive them? And perhaps more importantly, what should our response be to these mysteries? Should we be troubled? Should we be frightened? Or should we be excited? Should we be grateful for the opportunity to contemplate these profound questions? I would suggest to you that the proper response is wonder. Wonder and a kind of humility. Humility in the face of a universe far vaster and more complex than our minds can fully comprehend. Humility in the recognition that our understanding is always incomplete, always evolving. And wonder at the extraordinary privilege of being conscious beings in such a universe, able to observe it, to contemplate it, to gradually, gently, come to understand it more deeply. The ancient galaxies that Webb has discovered are old, remarkably, impossibly, beautifully old. And that means the universe has had more time than we thought to develop all the complexity we see today. More time for stars to form and die. More time for elements to be forged in stellar furnaces. More time for planets to gather around stars. More time, perhaps, for life to emerge and evolve in that vast cosmos. More time for consciousness to develop and grow. And time, it turns out, is perhaps the greatest gift the universe has given us. Not time as we experience it in our daily lives, measured in hours and days, but time on cosmic scales, measured in billions and billions of years, stretching backward into a past so distant and so deep that it approaches infinity. In this time, everything has become possible. And in this time, everything will continue to become possible. The story of the universe is far from over. Galaxies will continue to form and evolve. Stars will continue to burn and die. And perhaps, somewhere in the cosmos, consciousness will continue to emerge and grow, learning, as we are learning, the profound mysteries of the universe it inhabits. And so we arrive at the end of our journey together. Or perhaps not an end, but a pause. A moment of rest before the questions begin again. Because the universe never truly stops asking questions. And we, as conscious beings caught up in this infinite cosmos, never truly stop wondering. Let your breathing slow now. Let your body sink deeper into whatever surface supports it. There is nowhere to go, nothing that needs to be done. There is only this moment and this gentle contemplation of the cosmos and all its mysteries. Think about what you now understand. The James Webb Space Telescope has discovered galaxies that should not exist according to our current models. These galaxies are ancient, mature, complex, and yet they appear in a universe that we calculated to be far too young for such development. This discovery has opened new questions about the true age of the universe, about the nature of cosmic time, about the fundamental laws that govern how galaxies form and evolve. Perhaps the universe is older than we thought. Perhaps it extends further back in time than 13.8 billion years. Or perhaps the Big Bang itself is not the true beginning of all things, but a transition in a cosmos that is eternally old. Or perhaps there is some aspect of physics we do not yet understand that would explain what Webb has found. All of these possibilities are profound. All of them invite us to reconsider our place in the universe and our understanding of existence itself. But more than the specific answers, more than the facts and figures and cosmic measurements, there is something deeper that Webb's discovery teaches us. It teaches us that the universe is always more mysterious than we believe. It teaches us that there is always more to discover, always more to wonder about. It teaches us that existence itself is profound beyond words. As you float now in this place, between waking and sleeping, between knowledge and mystery, consider the vastness of cosmic time. Consider the billions of years that have already passed since the last of those ancient galaxies first sent its light toward Earth. Consider that light traveling through the void for eons and eons, eventually reaching our instruments, telling us secrets about the ancient universe. That light has journeyed for billions of years to reach you tonight. The photons that form the image's web sends back traveled through the cosmic void since the universe was young. And now they have brought knowledge to your consciousness, here and now in this quiet moment. What an extraordinary thing. What a miraculous thing when you truly contemplate it. The universe has connected itself to itself through time and space, through the light of ancient galaxies, and the instruments we have built to detect that light, and through your own awareness as you rest and consider these mysteries. You are not separate from the universe. You are not an outsider looking in. You are the universe, experiencing itself. You are made of stardust forged in ancient furnaces. You are a collection of atoms that have existed since the beginning of time, or before the beginning, if time itself had a beginning. You are temporary, brief, and yet eternal, because the atoms and energy that make you up are eternal. And in this moment, as you rest, you are connected to everything. Connected to the distant galaxies that Webb observes. Connected to the ancient light that brings us their secrets. Connected to all the stars and all the matter and all the energy that fills the universe. Connected to the mystery itself. Let yourself relax into this connection. Feel the weight of deep time pressing gently around you. Feel the vastness of space extending infinitely in all directions. Feel the infinite mystery of existence, beyond comprehension, beyond language, beyond thought. The universe has not finished revealing its secrets. Webb will continue to observe, will continue to send back images and data that challenge our understanding. Astronomers will continue to work, to calculate, to propose new models and new ideas. The questions will not be answered tonight. The mysteries will not be resolved. But perhaps that is as it should be. Perhaps existence is meant to be mysterious. Perhaps the greatest beauty lies not in having all the answers, but in contemplating the unanswerable questions. Perhaps the purpose of consciousness itself is to wonder, to observe, to appreciate the profound mystery that underlies all things. So rest now. Let your mind drift gently into sleep. Let the cosmic mysteries settle like snow around your thoughts. In your dreams, perhaps you will float through ancient galaxies. Perhaps you will see the light of distant stars. Perhaps you will glimpse, for just a moment, the profound beauty and mystery of the universe in its infinite depths. And know that when you wake, the universe will still be there. The ancient galaxies will still be shining. The questions will still be waiting. And the wonder, the infinite wonder at the mystery of existence, will be there too. The universe is old, older perhaps than we ever imagined. And that makes it beautiful, that makes it sacred. That makes it worth contemplating, even as sleep draws you down, even as your conscious mind releases its hold on waking thought, even as you drift into the peaceful darkness. There is nothing to fear in this darkness. It is the same darkness that fills the space between stars. It is the darkness where galaxies hide, waiting to be discovered. It is the darkness of deep time, of ages beyond counting, of mystery beyond measure. Sink into this darkness gently. Let it envelope you. Let it become part of you. And as you do, know that somewhere in the vastness of the cosmos, the light from ancient galaxies continues its endless journey toward you. That light has already traveled billions of years. It will wait patiently as you sleep. And when you wake, it will still be there, still carrying its ancient secrets, still inviting you to wonder. Rest now. The universe is eternal. And you, for this moment, can rest within its endless mystery. Sleep and dream of stars older than time. Dream of galaxies that predate our understanding. Dream of a universe so vast and so ancient that it makes all our measurements seem like the scratches of insects on stone. Dream of the profound beauty that lies in not knowing, in wondering, in contemplating the infinite mystery that is existence itself. And know, as sleep takes you fully, that you have traveled tonight beyond the edge of everything you thought you knew. You have journeyed into the depths of cosmic time. You have touched the mystery of the universe itself. This journey will continue, not tonight, but always, because the universe never stops revealing itself. And consciousness, wherever it emerges, never stops wondering. So rest, and in your rest, let the universe rest within you.